Now I'm going to talk about the knowledge base right here. The knowledge base, that is a collection of all the if-then rules we are going to deal with the problem. So like this one, that is the one we are talking about, the control of the distance of the car to keep a safe distance. And then so we have three rules, and then all these three rules will be given in will be stored in the knowledge base to support fuzzy inference engine or to do the reasoning. Yeah. So the number of rules, the number of input, and then the number of output, actually it depends on our application. In general, we will have this kind of rule. So the rules are problem specific. That means according to different information of the application, we will come up with different kind of rule. And then these rules, they are in linguistic format. In if, that means if, and then we have some premises, and then we are going to have the consequence. That means in the linguistic rule, we have if, we call this part that is the premises, or we call this is the antecedent. And in the then part, we call this is the conclusion, or we call this is the consequence. So the general rule format, that is, say we can have many rules from 1, 2, 3, and so on. The ith rule, that is, we will have if the first input x1, the next input x2. If we are going to have more input, we can have x3, x4, so and so. Now this x1, in our previous driving example, x1 we use distance, and then so we can use some meaningful names instead of just x1, x2. And then the same for this one, we have a fuzzy term here, a sub I1. So we can also use some meaningful labels, say small, medium, negative, positive. Yeah. And if we have more than one term here, so something like that, x1, x2 is something, we can combine them using the and as well as the fuzzy or operator. And later on, I'm going to introduce another one that is not. But anyway, here we have two examples. Rule 1, if x is small and y is negative. So we have the fuzzy term small, negative, two input variables, x and y. Combine these two statements with and. And then rule 2, instead of using and, we can use or. Yeah. So that means when we do the rule evaluation, we need to understand how do we interpret and as well as or. Yeah. Okay. Now we have more details. All these input we call the fuzzy variable or linguistic variable. Y, that is the output of the fuzzy inference system. Say in the output, if we have more than one output, we are not going to use and right here. So say we can have multi-input single output system. If you are going to have multiple input, multiple output fuzzy inference system, you can break it down into a number of multiple input single output system. Yeah. So we call this is the all these A right here fuzzy set, and B, that is another fuzzy set for the output variable Y, and then R, that is, for example, the rule number that is going from 1 to up to R, that is the number of rules determined by the designer. Okay, and once we have the knowledge base, we need to know how do we do reasoning according to the input, according to the experience right here. So that is, go back to just revisit our driving example. Once we have the input 3.5 meter, and then so we can have these rules by evaluating the contribution of each rule. Based on this information, we are going to do the fuzzy inferencing, and we come up with this fuzzy output. So the inferencing mechanism, that is what this fuzzy inference engine is going to do. Yeah. So we are going to look into the details, what we are going to do so that we come up with the fuzzy output that is in word, that would be a sentence, but actually it is a combination of some membership functions at the output domain. Yeah. Okay. And now the fuzzy inference engine. which is going to produce the output as I mentioned before. Now, we can break down the fuzzy inference engine into two processes. Rule evaluation, sometimes it is referred to implication, and then another one that is the rule aggregation. Rule evaluation, that is we are going to evaluate the contribution of each rule that is given by the if part. And then the rule aggregation, that is we are going to consider all the contribution of each rule and then put them together to form the final output. Yeah. Okay. So in order to do rule evaluation, we need to understand how do we define fuzzy or, fuzzy and, as well as fuzzy lot operations. Yeah. So in the next slide, I'm going to give you the example. How do we deal with this or, and, as well as not? When we do or operator, it is called union operation, and also it is known as T-norm or conjunction operator, the and operation, intersection operation. Also, sometimes it is referred to as T-column or S-norm. Yeah. Okay. And disjunction operation as well. Yeah. The fuzzy not operator, complement operation. And now this is a general picture, an example to show the picture about how do we do the rule evaluation. Say we have three rules, two input variables, x and y, and one output. So this is a system, fuzzy inference system with two input x and y, and the output that is z. So x and y, we are going to use some fuzzy terms to describe it. Small, medium, and large. The membership function are defined right here. For example, this is the small, the red, the green that is medium, the large that is blue. So negative right here, I'm going to use three membership functions as well. Negative, 0, positive. So this is negative, and then the green is 0, and blue that is positive. Okay, so I just randomly pick some membership functions right here because we do not have the specific application. So these membership functions are just for demonstration. X, Y in the rule 1, X is small, Y is negative, and then Z is low. That means we're talking about another membership function for low, medium, and high. Yeah, so I do not put it right here, but we can have low, middle, and high for the output membership function. Now, anyway, I'm going to show you the rule evaluation for the first rule. That means we are going to consider the whole statement in the if part. Assume that this is the x, the input 3.5, and then the y, that is the input at the moment, that is 1. So draw a vertical line. We will just find out that for small, x is small, the contribution right here, just this bit, the membership grade, that is 0. Okay, so this one, okay, so there's a typo right here. This is medium, and then this is small. So mu small, that is 0.25, and then mu medium, that is 0.8. Large, according to the red line, the membership grade, that is 0. Yeah. So again, the same for y. When we put the vertical line right here, we can find out that the membership grade for negative for y equals 1. That is this one, 0.0561, and then positive 0. That is right here. The membership grade 0.8007 for positive. Now note that we are talking about not positive. Okay, but anyway, we are going to evaluate y is positive. That is right here, 0.2780. And now we are going to deal with this AND operation. When we do AND, one possibility, that is just to use the minimum operator. So what we are going to do is just to find out the mu small value according to this figure. That is yeah, so that it is typo here, so it is 0.25. So find the minimum between these two. So the minimum, that is 0.0561. So we come up with this value. And then when we talk about the second rule, x is medium. So the mu medium x, that is, it should be 0.8333 according to this figure. So the maximum, so mu 0, that is 0.8007, the maximum between these two numbers, it should be 0.8333. Just pick the maximum amount between these two. And now, when we talk about x is large, mu large, that is 0. And then now we are talking about not positive. So positive right here, that is 0.2780. Not positive, that means 1 minus 0.2780. So again, because we use OR right here to combine these two premises, so we are going to pick the maximum one. Yeah, so this one just give you 0.7220. This is the maximum between these two. So the rule, after the rule evaluation, we come up with 3 numbers. This one just tells you that the overall contribution made by the if part, that is 0.0561. So the value is low and then very close to 0. So the contribution for rule 1 is small. Yeah. Okay. Now rule 2, 0.8333. Yeah. So it means that the input x and y satisfy more to medium and 0. So the contribution of rule 2 is higher. Yeah. And now the same interpretation for the rule 3. The contribution made by rule 3, that is 0.72220. Yeah. Okay. Now we understand how do we interpret the if part, as well as how do we define and, or, as well as not. So take a look at a more general picture about fuzzy OR operator. In the previous slide, I just used maximum. That means when we are given two fuzzy sets, so something or something, so we just simply find the maximum between these two membership grade. Yeah, so this is one option. Another option, we do algebraic sum. That means we could use this equation. Yeah, so that means right here, instead of doing maximum, we can apply this number, these two numbers, into mu A and mu B minus mu A times mu B. Yeah. For the AND operation, previously we use maximum. Find the maximum value between these two membership grade. Yeah. Find the max. Sorry, what I mean is minimum. Find the minimum between these two membership grade. Yeah. Now we can do product. That means multiply these two membership grade together to get the fuzzy AND operator. We have to define what kind of definition we are going to use to interpret OR as well as AND. Fuzzy NOT operator, or we call this is the complement operator. So if we are going to have mu A bar, it means that this is just the log operation. So we are going to do 1 minus mu A. So just like the previous example, not positive. That means first we find y is positive. Find this value first, and then 1 minus 0.2780. That is not positive. Yeah. Okay. Now, another example. In the previous example, we deal with continuous membership function, and now we are going to do evaluation for discrete fuzzy set. Consider only one rule remember that we can have more than one rule. 1, rule 2, rule 3, we follow the same logic. Now this rule is if x is small, x is the first input, so x is the first input, and then y is the second output, z is the y is the second input, z is the output of this fuzzy inference system. Now small is defined by this membership, defined by this fuzzy set. Just to recall that if we are going to draw this membership function, we are going to interpret like this. 1, that means the x-axis, this value is 1, is membership grade, that is 0. 2, right here, membership value, that is 2. 3, that means when the x-axis, that is 3, is membership grade, that is 1. And then 4, again, it is 0. So when we consider x, that is 3, so x, that is 3 as the input, y, that is 2 as the input, another input, and then mu small. So we are talking about mu small because we do an operator, so we choose the minimum. So mu small, according to this membership function, this one will give you 1. So y is negative. We can just simply put the function as well. 1, 2, 3, 4, 5. And then 1, that is 0. So the y value, that is 0. 2, this is 0.5. And then 3, that is 1. The membership grade, that is 1. 4, that is 0.5. And then 5, that is 0. Yeah, so it looks like a triangle. Yeah, when x, that is 2, it means that the mu negative. When the y, that is 2, and then it is 0.5 according to the membership, according to the fuzzy set. The minimum between these two, that is 0.5. So after the rule evaluation of the if part, it just gives you 0.5 as the overall membership grade. Yeah, so this is the rule evaluation for discrete fuzzy set. Okay, now we are going to look at a bigger picture. How do we put everything together from the fuzzifier, from the rule-based, as well as from the fuzzy inference engine during the rule evaluation as well as the rule aggregation? Assume that in the rule-based, we have 2 rules. The first one, that is x1 is a. Yeah, so again we have x1 as the input, and then x2 is a12, x2 another input, y is the output. So x is a11, x2 is a12. If you do not like this label, we can just simply assign a better label for that. If x1 is small, yeah, so this is the fuzzy set, small, x2 is large, then y is b1, or we call this is negative. For rule 2, x1 is large, x2 is small, then y is positive. Yeah. So in this figure right here, this is rule 1. So rule 1, if x1 is small, that is, I just put the membership function or the fuzzy set a11, that is small right here. I just draw the membership function, and then x is large. This membership function, that is the x-axis, that is x2, and this represent large. And then this is rule 2. Rule 2, this one, x1, the x-axis represent x1, this membership function represent large. And then x2, that is the x2, that is the second input, and this membership function right here, that is represent small. Now note that this small, that is the small for x1, it is not the small for x2. Yeah, so we refer to different contexts. So just like what we use our language when we say that the room is small, that kind of scale of small, that is different from say the bottle is small. Yeah, they are in different scale. So small bottle, the meaning is different from small room. Yeah, from the small of the small room. So that is exactly the same meaning right here, the same interpretation right here. This small is different from this small. Okay, in the previous figure, in the previous example, we put all these membership functions together. For example, for x1, we have, this is small, large. Now I just simply separate these two membership functions from one figure into two figures according to the rule. Okay, so this is B1, B2, or we call this is negative, and then this is positive. According to my design, I have two membership functions for y in rule 1 and rule 2. And now I consider that to handle the AND operator, I use min. That means I'm going to use the minimum operator to deal with the membership grade given by x1 and x2 for these two fuzzy set. And then the inference method, we call this is the max min. I'm going to explain this later. Now assume that in this system, x1, x2 as the input, y is the output. x1, that is this value. So I draw a vertical line. This vertical line extends from the bottom to the top. That means if we have more rules, and then so each rule, the x1 will be the same. So that's why I draw a vertical line. It cuts across this point. When you look up at the y value, that is the membership grade. The same for y2. The same for x2. Draw a vertical line. They are subject to the same value of x2. Yeah. So it cuts across the green line in the y-axis. It cuts across the green line at the y-axis, so we know what y values they are at the moment. But anyway, according to the intercept, I draw a horizontal line like this. The reason why I draw a horizontal line, because I'm going to do the rule evaluation. That is the minimum operator, because we combined the rules using the AND in rule 1 and rule 2 as well. Because this is the minimum operator, so I'm going to pick the minimum value among these two, among this one and this one. That means I'm going to pick this one because this is the membership grade for rule 1. And then the same, draw a vertical line, horizontal line, pick the minimum value among between these two, just like what we did before handling the AND operation. Okay, so this is about the AND operator. And now what I'm going to do is just to do the rule aggregation. In this column, as I said, this is the first triangle is from the first rule, the then part of the first rule, and then the next triangle right here, that is the second rule. Yeah. And now this figure right here, actually the x-axis, that is y, that is this axis and this axis. The y-axis is mu y, that is the same y-axis right here. So why I put an extra figure right here? Because I would like to put the information into another figure. Yeah. Now, after I determine the minimum grade for each rule, so I extend the horizontal line to the output membership function for rule 1 and then for rule 2. Now, to interpret the inference method, max min, first I'm going to do min. Now I'm going to do min. That means we have two lines right here. This is the line given by the rule evaluation. The next line, that is about the triangle membership function. Compare each value in this line with the triangle value. Pick the minimum value. So we come up with this one. Because say in this portion, this value are all larger than the blue line right here. So I take this as the output. And now when we compare this horizontal line right here with the upper triangle, all these values, they are higher than this dotted line. So we come up with this line. And then compare this portion with this blue line right here. So these values are higher than the lower value right here. So we come up with this one. So that's why when we apply the mean, and then so we have the gray area. Yeah. So we have the gray area once we perform mean. So the same thing for this one. The horizontal line compare with the blue line, we pick the minimum value. So that's why we come up with this gray area. Yeah. So put them together. The first gray area from here. So this is the first gray area. And then the second gray area, that is from here. Now we are going to put everything together. Now we are going to perform max. So max, it means that the first gray area, that is this one, and then the second gray area, that is this one. The max, it means that we are going to go through every value from the left to the right. So we are going to check this value. Yeah, do not forget that even though I do not draw any line right here for this membership function, the membership value actually that is 0. Yeah. Okay. So compare each value right here with the next membership function, the second membership function given right here. These values are higher than this value. So we are going to pick the one with the maximum value between these two. So in this region, all membership grades, they are higher than this one. Up to this point, we just find out that the second membership function, the membership grade are higher than the first membership function. Yeah. So that's why when we do max, actually, we just find the end fruit. That would be the aggregated output. Yeah, that is the aggregated output membership function. That is this shape. So when I say the aggregated membership function output, that is the one right here. So that means if we follow that fuzzy inference method, we will come up with the membership function, the output membership function like this. That is the gray area. And now I'm going to give you another example. The example is very similar. The only difference is that instead of using max mean, I'm going to use the max product. Yeah. So the AND operator is mean, and these two roots, they are exactly the same. Yeah. So we just follow the same logic, get the input, and then find the membership grade for the x1, get the input for x2, and then so find the membership grade in the intersection point of the grade of the green membership function. And now I'm going to do the rule evaluation, because we use the mean operator. So we come up with the same horizontal lines right here. And now I'm going to exercise the product for the inference method. This line times the membership function, it gives you these two shapes. The same applies to the lower membership function. The blue line right here, the blue triangle, multiply the cyan horizontal line, it gives you the gray area. Now the max, that is when we put these two triangles, the gray triangle together, and then just take the maximum value of the aggregated fuzzy output. So this is so that's why we obtain this as the fuzzy output membership functions. Yeah. Okay.